Our lesson on 9.6 is going to have a solve rational equation. So we've added and subtracted rational expressions, we've multiplied and divided rational expressions, and now we're going to solve rational equations. So you're going to notice if it's an equation because it's going to have an equal sign. So for instance, on number 1, we've got the denominators are x, 3x, and 3. Now because these are equations, instead of getting common denominators, we're actually going to wipe out the denominators completely. So big parentheses around the whole equation, and I'm going to multiply through by what would have been our least common denominator. So our least common denominator would have been a 3x. So we're going to take this 3x and we're going to multiply it to everybody in this equation. Now I'm going to write this one out the long way at first, just so you can see what's happening. So it's 3x times 7 over x, and then minus 3x, whoops, help if I could write, 3x times 1 over 3x, and then equals 3x times 5/3. So now each one of these little problems is a multiplication problem, but you're going to see that some things cancel. For instance, in this first one, the x's are going to cancel, and you're just left with 3 times 7, which is 21. In this next problem, the 3 and the x are both going to cancel, so it's really just a minus 1. And then in this last problem, the 3's are going to cancel and leave you with just 5x. So now I've got a nice linear equation that we can solve. And if you divide both sides by 5, you get x equals 4. Now there's a slight catch to this kind of a problem. Once in a while you'll get a solution, but if you were to plug it back in, it actually wouldn't work. When that happens, this is called an extraneous solution, and I'll show you a shortcut for finding out whether it's extraneous. If you look at your denominators, when you plug in your answer, if it ever would produce a 0 in the denominator, that would be an extraneous solution. And we can tell pretty quickly that if I plugged in a 4 for any of my denominators, it would never end up giving me a 0. So x equals 4 is a legitimate answer. Okay, on number 2, we're going to do the same process, except we need to really see that x squared minus 4 is really just an x plus 2 and an x minus 2. Okay, so now I'm going to put big parentheses around the whole problem, and I'm going to multiply through by my common multiple for my denominators, my least one. So it looks like we would have had an x plus 2 and an x minus 2. Now you're going to distribute this to all 3 fractions. And what's going to happen is some part of this, maybe all of it, would cancel with the denominator in that particular fraction. So in this first fraction, the x minus 2's will cancel, so you still have a 3x times the remaining x plus 2. Because do you see that this x minus 2 and this x minus 2 would cancel out, but you still have x plus 2. Now in the next fraction, the x plus 2's will cancel. So you really just have a 1 times the x minus 2, which is really just x minus 2. And then really nice, in the last fraction, both the x plus 2 and the x minus 2 will cancel, so all we have left is a negative 4. So we no longer have any denominators, we just have, this time it's a quadratic equation. So when I distribute the 3x, we get 3x squared plus 6x, and then there's still a plus x minus 2. And we know when we want to solve quadratics, we have to set them equal to 0 and solve. So if I combine my like terms here, let's see, add the 4 over, so that would really be a plus 2. And of course, we're going to factor. Let's see here. How about a plus 2 on the end, because that'll give me a 6 on the outside and a 1 on the inside. Now when you go ahead and solve both of these factors, you get negative 1/3 and then negative 2. But think about your original denominators. Look at your original denominators. If at any point you were to plug in your answer and it would produce a 0 in the denominator, any of them, that's an extraneous solution. So you see right here, x equals negative 2. If you were to plug it into this denominator or this one, you would end up with a 0 denominator. So what I want you to do is cross it off like this and write ext next to it, meaning that it's an extraneous solution, which means it shows up algebraically, but it doesn't actually work for our problem. So the only solution to number 2 is x equals negative 1/3. Okay, something very similar here on number 3. Our common denominator would have been an x plus 3. So when I distribute that into the first fraction, x plus 3 cancels with the x plus 3, giving me 2x. Okay, the next part doesn't have anything to cancel, so it's still going to be a negative 5 times the x plus 3. And then the last fraction, the x plus 3's will cancel, and you just get a 1. So this turned out to be a really nice, easy problem. Let's see, I ran out of room here. Negative 3x, if I add the 15 over, get a 16, so x is negative 16 thirds. And I do a quick double check. If I tried to plug that in here, it wouldn't give me a 0. The only thing that would give me a 0 is a negative 3, which I don't have. Okay, our next problem. What I'm going to multiply by would be our common denominator, which would be a 3 and an x. So if I were to distribute that to my first fraction, the 3x won't totally cancel, but the x's will cancel. So the x's are gone, and you just have 3 times 3, which is 9. Now for the next fraction, nothing's going to cancel, so you have 3x times 12, which is 36x. Okay, equals 3x times 2, which is 6x. And then the last fraction, 3x and 3x will cancel, giving you a plus 4. So I'm going to bring my x's to the left. Let's see here. That would give me a 30x equals, bring that over, negative 5. And be careful, don't divide upside down here. Negative 5 divided by 30 is a negative 1/6. And I just got a quick double check. If I were to plug that into either denominator, that wouldn't give me any zeros, so we're good to go. Okay, number 5. We're going to multiply through by the common denominator of x plus 1. So for the first fraction, that works out beautifully because it's just going to cancel. Same thing happens here on the last fraction. So 5x, the 4 is still going to be multiplied by the x plus 1, and then minus 5 because the x plus 1's cancel on the last fraction. So when I distribute my 4, I get x equals negative 1. Now at first glance, everyone would just circle that and think they're done, but go back up to the problem. Do you see that if you were to plug in a negative 1 to either one of those denominators, it would give you a 0 in the denominator. So this is actually an extraneous solution, which means since there are no other solutions left, this problem has no solution. Number 6 would have had a common denominator of 2x. So if I was to multiply the 2x into the first fraction, the x's would cancel, leaving you just 2 times 3, which we know is a 6. In the next fraction, the 2's would cancel, so you'd just be left with 1 times x, so x. And then in the last fraction, the x's would cancel, so it's really just 2 times 12, which is 24. So some of them, like this one, for instance, is very, very, very easy. And of course, negative 18 wouldn't give you any problems when you plug it into the original equation. Okay, our next example, we need to realize that x squared minus 1 is really x plus 1 times x minus 1. So when I multiply through by what would have been my common denominator, that's an x plus 1 and an x minus 1. Let's see here. In the first fraction, the x minus 1's cancel, but you still have a 5x times the x plus 1. Okay. Now the negative 2 is going to multiply by both the x plus 1 and the x minus 1, so I'm going to kind of cheat, and I'm just going to change that to x squared minus 1 because I know I'm going to have to FOIL it out. And then the last fraction, both of them will cancel, so you just have a 14. Now a little bit of a bummer here. We're going to have a quadratic, which of course means more work. Alright, if I collect all my like terms and make everything say equals 0, looks like I've got 3x squared plus 5x, let's see, minus 12. So we're going to factor and get up to 2 solutions. It might not be any solutions, actually. We're going to have to check. Well, I know it's 3x and x, and then I got to do a little thinking, because 12 could be 6 and 2 or 3 and 4. So I'm thinking... negative 3, yeah. So positive 3 here, and a minus 4, because that would give you 9 minus 4, which is 5. So one solution is 4/3, and the other solution is -3. And if I look back at my denominators, the only thing that would have got me in trouble is if I had a positive or -1, which of course neither of these are. So this is a case where the solution is actually two different solutions. 8 is actually really simple. Because there's only one denominator in the problem, you're just going to multiply everybody by an x. Now this first fraction, it's an x over 1. Nothing cancels, so it's an x squared. The next fraction, the x's will cancel, so it's just a 24. And then 5 times x, there's nothing to cancel, is a 5x. So again, we've got a quadratic. Whoops. So if I bring the 5x over, and then of course factor and solve. How about -8 and +3? And when I solve, I get x equals 8 and x equals -3. And if I look back at my problem, the only thing that would have given me trouble was a 0, which obviously that is not. This is a -3, by the way. It's kind of hard to tell. Okay, number 9. Yuck. I think that last denominator is going to factor, and if I had to take a guess, I would say these two things are going to be its factors. So let's see if that works. So that'd be a -6 + 2 is a -4. Yep, that works great. So big parentheses around the whole problem, because it's an equation. We're going to multiply everybody by a 3x + 2 and an x - 2. So this first fraction, the x - 2's will cancel, but you still have a 2x times the 3x + 2. Our next fraction is going to cancel the 3x + 2's, but you still have, and this is kind of weird, you still have a negative. You need to put the 4x - 1 in parentheses because you're going to have to distribute that negative later on. And he's also going to have to multiply by the x - 2. We got a lot of simplifying to do here. Now good news, the last fraction, both of them cancel. Okay, let's distribute the 2x. We have 6x squared plus 4x. Now here, I'm going to hold on to the negative, and I'm going to go ahead and FOIL those two together. Well, 4x times x is 4x squared. And then we're going to have a -8 - 1, so -9x plus 2. Take care of that negative in a second. You don't want to skip so many steps where you start making silly mistakes, because even a tiny mistake is extremely costly on this kind of a problem. So we definitely have a quadratic, which is a little bit of bad news, but that's okay. Now we're going to distribute the negative to that trinomial. And because it's a quadratic, we're going to have to bring everything to the left and collect our like terms. So I've got a 2x squared. Okay, that would be a 13x. I don't know if you can hear the bells, but the bells are ringing. 13x, and we're going to subtract the 17 over. So 13 minus 17 is a -4x. And then we have a -2, but I would take the 4 over as well, so that's a -6. Oh, good news. This quadratic has a common factor of 2 that I could go ahead and divide by. So we have a much nicer quadratic. I always like to divide by that factor if I can, because now I have a really easy factorable quadratic. That'll be an x - 3 and an x + 1. So my two answers are x equals 3 and x equals -1. And if I look back at the original denominators, neither one of those answers will give me a 0 in either of my denominators, any of my denominators. So those are both legitimate answers. Now this next section says you can cross multiply. And the reason we can cross multiply these problems is because it's just a single fraction equals a single fraction, as opposed to our previous problems where it was more than one fraction either being added or subtracted on one of the sides of the equation. So if you remember cross multiplying back in the day, your butterfly wings, we're going to multiply 2x plus 3 times the quantity times 2. So you have 4x plus 6. And then for the other diagonal, it'd be 2x minus 10. And then you solve it. We're going to subtract 2x, and then subtract 6. Divide by 2, of course. And the same rule applies, that if your denominator were to end up being a 0, then you would have an extraneous solution. But turns out it works out great here on number 10. We're going to do the same thing here on number 11. Cross multiply. It doesn't really matter where you start, but I always like to start with what will end up being my lead coefficient because I like it to be on the left. So I notice here we're going to have a quadratic, so I'm going to do that one first. So x squared minus x equals, and then 2 times this would be 6x minus 10. So we have x squared minus 7x plus 10. How about x minus 5 and x minus 2? So my two solutions are x equals 5 and x equals 2, and if I look back at my original denominators, nothing is going to come out to 0 if I were to plug those in. So we're good. Ooh, this is an interesting problem. We can go ahead and cross multiply. It'll work fine, and yeah, we'll have a quadratic. But I don't know if you noticed this, the 6x minus 2 is actually removable because, or the 3x minus 1 is. If you factor out a 2, you'd have 3x minus 1. And I don't know if you noticed this, but the 3x minus 1's, top and bottom, are in common. Now let's not approach this question this way. Let's go ahead and work through the quadratic. So 12x squared, oh, well, that's interesting. If I start with either diagonal, I end up with 6x minus 2 times 2x plus 5 equals 3x minus 1 times 4x minus 13. So we're going to FOIL 12x squared. We've got 30 minus 4, so that's, let's see, plus 26x minus 10. I'm going a little fast, Mimi, slow down, you go ahead and pause this. 3 times 4 is 12x squared, that's interesting. Negative 39 minus 4 is a negative 43, I kind of lost track of that. And then plus 13. So this is kind of interesting. The 12x squareds are going to end up canceling, which is great news because that means we no longer have a quadratic. So if I were to add the 43 over here, and then add the 10 over here, that's a 10. We would end up with, let's see, 69x equals 23. And then of course we divide by 69. And you get x equals 1/3 now. A little bit of a catch. Remember what we said about our denominators not being able to be 0? If you were to plug in a 1/3 right here, 6 times 1/3 is 2. 2 minus 2 would give you a 0. So it turns out that's an extraneous solution. And since there's no other solutions in this problem, there is no solution. That is lesson 9.6. Good luck.